Good morning and welcome to the Blast Blocker webinar. This is a little bit of a deviation how we normally run webinars. Typically, they are for our reseller partners. Today, we've invited several of our mining customers to join as the information we are presenting is specific about a application we've been developing for the mining industry. The point of the call today is to get our customer feedback prior to releasing this application. So we are not making a offer to sell, but we would like to present what we've been working on, get your feedback, and make changes as necessary. So when we do roll this out, we meet the customer requirements. My name is Todd Rigby. I'm a director of sales for Rajant. I'll be your host. With me today is Muthu. Let me say that again. Muthu Chandrasekaran. He is our VP of Artificial Intelligence at Rajant Health and the principal developer behind the application. And he'll be sharing some of the background of what we've put together. Our objectives today are to bring you up to speed on our product development status. We'd like to get feedback from our partners and our customers. We'll share with you possible future enhancements that we're working on. And as I said, we'd like your ideas for what's needed to make this best-in-class product. And we also want to demonstrate the application in kind of a live format. Next. The background for this application is we are trying to provide, our idea is to provide a supplemental situational awareness tool to assist in the blast operation of open pit hard rock mines. I want to be clear, we are not making any safety guarantees, but we do believe that every mine should take every possible precaution to operate as safely as possible. And we think we can leverage your investment in Rajant and some additional technology to give you some added tools and added visibility. From a user responsibility standpoint, most mines follow more or less the same process for their blasts. I'll kind of review it quickly. We're not encouraging anyone to stop doing what they're doing now. We're only offering an additional enhancement that you can add to what you're already doing. And the idea of this application is that it will have continuous improvement. Like any software application, there will be future versions with additional features and capabilities. But our hope is that with your valuable input, voice of the customer, we can roll out the best possible solution when we do release this in the coming weeks or months. Next. So for anybody working in a mine, this is going to be redundant. I apologize, but I do want to make sure that those from our reseller channel who may be joining us that aren't familiar with open pit mining at least have an understanding of what we're talking about. So a very common application in open pit mining is to drill on a daily basis, load those drill holes with explosives, and detonate those explosives to fragment rock such that it can be loaded into trucks with large shovels. This is generally referred to as the drill and blast operation. There are currently many safety provisions in this operation. Typically, what happens globally is the blast supervisor will identify a number of individuals. Sometimes These are the same individuals every time. Sometimes it's an ad hoc group. And these individuals are referred to as blast blockers. They are not blocking the blast. The point of a blast blocker is to block access to the blast zone. The blast zone is a defined area around which the holes with explosives are located. Beyond the blast zone is an additional safety zone. The safety zone is set based on the mine. Each mine has their own safety zone. Sometimes there's a single safety zone. Other mines have dual safety zones, one for equipment, one for personnel. We can accommodate up to 2 safety zones outside of a blast zone. The blast blockers typically travel on different access roads to the edge of the blast zone, make a visual inspection, and then back up those access roads to which they're assigned to monitor and block to a point beyond the safety zone. What the specific problem we're trying to avoid is we are aware that there are near-miss incidents where blast blockers misjudge the distance of the safety zone, and they remain inside the safety zone, and unfortunately, in some occasions, their machines or light vehicles are hit with falling debris from the blast. We believe the predominant reason for this is because there's not an easy way for the blast blockers to actually monitor exactly what their distance is from the blast zone. And our hope is that we can help you identify that with the use of technology. So with that, I'm going to turn the time over to Muthu to kind of explain what we've put together with our application we're calling Blast Blocker.
Thanks, Todd. I appreciate it. And thanks everybody for attending and your time. So today we are going to talk about Blast Blocker. It's an application that Rajant Health has developed. It provides situational awareness and operational awareness to augment the safety measures that you guys, the folks in the mines, have already put in place during blasting events with comprehensive real-time worker and equipment monitoring at the edge. And the ecosystem for Rajant Health involves familiar components to you, Rajant breadcrumbs, and a lot of mining customers have already a Rajant mesh network in their ecosystem. And we have developed infrastructure that can just go on top of that ecosystem. We've developed an edge computing platform called the Cowbell. It is a distributed computing hub and platform as a service that includes the hardware, software, and the networking infrastructure to simplify the delivery and management of AI applications at the edge. And one of those applications that it hosts today is the Blast Blocker application. And it hosts the entire application locally and provides a web-based interface for the Blast Blocker application to be pulled up on a tablet, mobile phone, any computer that has a web browser. And the other component of this platform is the QStat, which is a wearable device. It is a wearable hub designed to deliver individualized network resilient health and safety monitoring of a personnel. And it can track personnel health and GPS location in real time and transfer that over the Wi-Fi mesh network into the Cowbell where the application is hosted. And this data is then being received by the Cowbell, and we have proximity detection algorithms and safety zone creation algorithms that we will talk about that enable each personnel to be identified as whether they are within the blast zone or outside the blast zone. And I'll show you incremental demonstrations of each of these as we go along in the presentation. The final thing is the equipment that are currently typically equipped with Rajant breadcrumbs. They also have GPS in them. And we are able to track equipment using the GPS within the Rajant breadcrumbs They can also be used to deploy Wi-Fi access points to transmit the data from the QStat, because QStat is a Wi-Fi client. So it just connects into any access point within your mesh network, and it provides the breadcrumb provides the low latency, high reliability communications. So one thing I want to make clear here is that um, um, as a blast supervisor or a blast master, only infrastructure you need is a computer with a web browser, and you need to connect into the network for you to be able to pull up the application. It could be a tablet, it could be a mobile phone, or anything of that nature. Another thing that I wanted to talk about is that some of our customers may already have breadcrumbs in their infrastructure. It's just very easy to add our cowbell into that platform by just turning these on and configuring the mesh network using a Rajant BC Commander, which some of you guys are already familiar with. So let's get right into some of the features of the Blast Blocker application. The first feature is a unified dashboard that provides the visual awareness that is needed for visualizing the blast zones and the perimeters to view personnel and machinery locations, health metrics, and operational data into one singular interface. And I will talk about different components of this interface as we move along in this presentation. So as you're seeing snippets here, we have developed multiple detail pages to dive into the data from each of these the variables or the breadcrumbs in detail if you wish so. We also have alert pages that you can dive into some of these alerts and look at how to resolve them, or if you need to perform analysis downstream. So the first main feature that we have is the creation of the hazard zone. We are able to do that in several ways. You're seeing now one way of creating that hazard zone. You could create interactively in the map, create a polygon like I'm showing here. And it automatically, as you can see, as soon as the polygon was created, you can see two safety zones that are immediately and automatically generated based on a configuration that we can set up at the time of provisioning the application. So we have one radius that represents the safety zone of the equipment, which is represented in green, and the other radius that is represented in red, which is your personnel safety zone, which is a little bit farther in typical use cases. And then on this user interface, so this is another way we can update an existing hazard zone by just dragging some of these points and clicking OK. And this is what you're seeing now. And it adjusts the safety zone accordingly. And we see that the concentric circles that you see, that it guarantees that the safety radius is met. So every single point in that safety radius is at least or greater than 600 the safety radius. So another way of creating these safety zones is by importing the safety zone. If you already have a blast zone planned and you have a geo-referenced blast zone that you've created, we can upload that into the platform as well. And that automatically creates the safety zone based on the hazard zone that was downloaded into this platform. So this is the third way.
Can I interject here, Muthu?
Yeah, sure.
So this importing of the file, kind of what we had in mind is if your mine has a sophisticated planning department and they make up graphics files representing the blast zone, that file can be imported into Blast Blocker such that it's very specifically representing the planned blast zone. So what we're trying to demonstrate is that, yes, we can take your graphics file from the planning department and build the the safety zones around the blast zone, or if your planning department doesn't make those files, you can also use a aerial map within the Blast Blocker app to manually create the polygon around the area that's being blasted that day. We had one question from Rain Sade in South Africa. Do you want to go ahead and ask that now, Rain?
Hi guys, yes, can you hear me?
Yes.
Yes.
Okay, yeah. So I mean, in terms of that, you partially answered my question there, Todd. The main thing is, I mean, we do have our systems, and I mean, from that portion, we can provide it via our ArcGIS platform as an API or a specific URL. And I mean, you guys know the mine plans changes quite often, so aerial views of third-party maps is not always as representative to the actual plans that we've got on site. So the question I've got here is, do we have that option to actually integrate with APIs into Blast Blocker, having our maps that we do have used published into there, and then of course, when they do have the blast radius and everything planned out, can we just have an import directly into it instead of just a JSON file or something like that?
And yes, absolutely. I think we can directly, if there is an API that you can expose for us to import blast zones directly from whatever software you have, we can enable that. If you have another map that you use for tracking your personnel, we could also. I'd like to think about how that interface would work if you're just using a different mapping system. We use OpenStreetMaps, and it's a little bit different from ArcGIS. But we can definitely import a georeference GeoJSON file into this platform and represent and enable the exact same functionality. Automatically create the safety zones and so on.
Yeah, typically we do sort of WTS sort of formats in our ArcGIS. That is a URL that you can reference. And would like to see that as the base map instead of a Google map or a satellite view from wherever what constellation you use for your maps.
Understood. Yeah, I think that would we'll have to talk. I think we should talk offline and talk about what that integration would look like.
One suggestion I'd ask, Rain, if you could send me an email with the file formats that you use for your locally created maps, as well as the mine plan drawings for the blast zone, then we can verify that we already have, or that we build in support for those.
Okay.
Oh, thank you.
Let's continue.
All right, going to the next slide here. So this is the location tracking capability I wanted to show you. So we did a live demo outside the building here in Melbourne. It's a 5-minute video, so I'm going to kind of fast forward this. So you see what you're seeing here. Let me kind of set this up. So you see this green guy in the bottom down here. Are you able to see my screen properly? So there's this green guy down here. It's one of my guys wearing a Q-stat and walking around in outside in our parking lot. And he walks pretty slowly, so I'm gonna kind of forward it. And these blast zones are not small, so I'm gonna really, as soon as you exited, you see there was an alert that was generated on the side here. It says exited blast zone. So it shows that this is the personnel safety radius, and as soon as he got out of that personnel safety radius, there was an alarm that essentially is an informationary alarm that said that this person has exited. And now he's going to walk around the parking lot, come back in a little bit. He's probably went out for some coffee or something. So he's coming back in, and I'm gonna start playing from here. So as soon as what would happen now, as soon as he enters that zone, you're going to see on the right the total safe assets go from 2 to 1. You'll see that shortly. There you go. You see it goes from 2 to 1, and then if you look, you can see the alarm that was generated saying that that person is back in the blast zone. Essentially, this is the idea. You have different equipment have a different blast radius, so we take that into account when we compute the safety zone or safety radiuses. And offline, we can also generate heat maps like you're seeing on the right-hand side here that showcases how long they spent, where they spent that time, and we can do a lot of analytics through the platform. The other thing we enable here is the continuous vitals tracking. And if this is something that you guys need, in addition to providing positional information from the QStat, we are also able to provide basic health metrics. This is something that every organization has different policies and procedures for collecting different metrics, health metrics. So this is something we can turn on or off as needed. Depending on your application. Finally, as you know, and we mentioned this, our entire system can sit on top of your existing mesh network. So one of these things is not like the other. One of these things, like the highlighted one, the CB node, is in fact a cowbell, and it has an embedded breadcrumb within it. So it interfaces with all of the other existing breadcrumbs automatically, and it discovers them. In addition to being just an existing mesh node, it can also cluster the compute resources on top of that, leveraging the mesh networking capability. So it really is a powerful platform if you want to deploy not just a blast blocker application and you want to deploy something else, you can use the same infrastructure. It increases the value of your infrastructure. Another capability we expose is notification systems. You can directly send alarms and haptic feedback for personnel wearing QStats. So even though a supervisor has got operational awareness, we would still like to communicate the same awareness into the blast blockers themselves. And in this case, we make that happen by activating a haptic feedback every time they're inside a blast zone. And if they leave the blast zone, the haptic feedback stops. We can also enable messaging. There are variants of the QStat that have a display where you can actually send a message saying you're still inside the zone. The same alerts that you saw that could be sent to the supervisor, we can send them directly to the QStat itself through the same Wi-Fi infrastructure. Another thing that you can do is you could have the supervisor manually trigger alarms or send messages to a particular QStat through their user interface. Another thing we talked about was the supervisor's alerts. So these are the alerts that it's a history of all the alerts that have happened throughout the blast blocking project session. And you can have the supervisor go in and acknowledge the alerts, resolve them if needed. Some of these things get automatically resolved if you leave the blast zone. So, and this is just a place where they can actually scroll through, filter your alerts, and do some analytics if that is something that they want to do for auditing and other purposes. We enable multiple levels of security for the application. First is it's a locally deployed solution, which means that only computers and people within the network can access the application. Second, we enable role-based access control that allows specific types of users to have specific types of capabilities within the platform. And we have standard, I see a question from Rain about AD integration. I think this is something that we don't currently have, but we can enable it in a future release. This is our authentication system also sits completely locally, and the objective for us is to enable this application in a completely air-gapped environment. So we don't technically need access to any outside cloud infrastructure for enabling this application. And with that said, I'm going to show some actual demonstrations. I can pause for questions briefly, and then before going into the actual demo.
I'd kind of like to do just like a 2-minute review to make sure everybody understands. So if we were going to imagine deploying this at a mine site, let's assume we already have a Rajant network deployed. You would hang up somewhere within range of your breadcrumbs a cowbell, which is an edge server with an embedded breadcrumb in it. And the cowbell hosts the application that has everything you need from the software to collect the locations, as well as the web server for the user access. You would also give each of your blast blockers the QStat wearable, which has GPS in it. And you would want to ensure that the machines or light trucks they were driving had a breadcrumb with a GPS on them. And that breadcrumb would need to have Wi-Fi access enabled so that it could transport the location data off of the QStat. It's important that we track both the machines and light trucks as well as the people, because we can't guarantee a person won't get out of the machine or out of the light truck. So it might seem a little redundant, but it ensures that even if the operator gets out of the machine or the light truck, we're still able to discreetly track them in addition to the machine or the light truck. As far as the supervisor goes, he would use his own tablet or smartphone to go to a web address through whatever browser he has on his device. The web address would be on the cowbell. So he's not going on the internet. He's going to a local web server hosted on the cowbell to see the images of the application that Muthu was just demonstrating. If you wanted to take it one step further, you could also tell the blast blockers the URL for the application so they could see their position relative to the safety zone. And now, rather than guessing, are they far enough away from the blast zone to be safe, they can see that they're outside of the safety zone. And Muthu I might be getting ahead of Muthu, but we've essentially added 10% to any number that you enter for the distance of your safety zone to accommodate for GPS error. We are not using high precision GPS at this point. We're just using standard GPS. And so we add 10% to whatever distance you enter in the setup for your safety zone to ensure that they are in fact at least that far away.
And I would like to add here briefly that in addition, the 10% also includes the error stack up for computing the concentric polygons and the distances. So typically there's a 1% error that we have noticed when we did our analysis to when computing these concentric polygons from the hazard zone. That was another reason why we added a 10% buffer.
Todd,
Yes,
the cowbell, just mentioned you just hang a cowbell. It's actually a breadcrumb node that you hang out just one, or is there like multiples that you use like all over the mine site, or does it even have to be out and about? Can it just be plugged in at a server room?
it could be in a server room. It just needs to have connectivity to the mesh network, but it is a weatherproof device that can be outside, like one of our Hawks or Peregrines, and it does have a breadcrumb in it, so it can interface and have mesh connections to other breadcrumbs.
And to add to that, typically, if you're looking for a fault tolerant, high available cluster, the Cowbell OS, there are features within the Cowbell platform that allows you to automatically do that and reallocate applications and maintain survivability and ensure that the applications are always up and running. We have orchestration systems and service discovery mechanisms to make sure that these things, the applications are always monitored for uptime. And so in order to enable a fault tolerant cluster, you need to have at least 3 nodes to give you a 1 node failover tolerance. And so it depends on the criticality of this and the mobility that you need. You can put a 3 node cluster in anywhere in your network to get you the high availability.
Gordon asked a question. Do you want to ask it out loud, Gordon?
Sure. It's actually 2 questions. The first is do you recommend at a certain size of the mine or size of the network to add a second cowbell into the network? And then the second question is, do you recommend having a second cowbell no matter what, just for redundancy's sake?
Yeah, so I can answer that question. So there's like I mentioned, in order to get you the failover tolerance, you would need at least 3 cowbells to get you 1 failover. So 1 node goes down, you'll still have the applications running like as if nothing happened. We have data redundancy mechanisms and synchronization mechanisms to make that happen, to ensure no data loss. But in terms of the throughput and the number of devices we can handle with 1 cowbell, each cowbell is independently, it's got enough compute capability to handle upwards of 700, 800,000 devices. We've not really reached an upper limit on some of this stuff. So in terms of the data throughput coming out of the QStats, including the vitals information, we generate about 1 or 2 kilobytes per second worth of information. So that adds up. If you have 1,000 QStats, you have about 1 Mbps, and this is almost nothing in your when you talk about your network bandwidth and throughput capabilities of the wireless mesh network that you guys might already have. But we would like to also account the reason why the cowbell is pretty beefed up is because we consider this as a platform for you to add potentially not just this application, but other value-added applications that you can manage within your platform, including things like cameras and other things we can talk about later. But yeah. I hope that answers that question. In terms of throughput, it's pretty capable to handle several hundreds of devices. Just a single node is. But if you want failure tolerance, there is a minimum requirement of at least 3 nodes to get you 1 failure tolerance, 1 node of failure tolerance.
So one thing we haven't really talked about, 1 second, Rain, and I'll get to you, is when does the blast supervisor refer to blast blocker in the blast process? Currently today, when all the blast blockers pull back outside of the safety zone, the blast supervisor would typically get on his 2-way radio within his radio group to the blast blockers and take a roll and ask each of them is your area clear and are you clear? We would completely encourage you to continue this process, but as the supervisor's taking this roll call, now would be a great time for him to also check the blast blocker display on his device to confirm that when the blast blockers tell them they are clear and outside of the safety zone, he now has a visual reference to confirm that they are in fact outside of the safety zone. Rain, do you want to ask a question?
Yeah, I think I've got a few. Okay, so first of all, I think the one was, does the web interface support HTTPS?
Sorry, can you repeat that?
The web interface for blast blocker, is it HTTPS?
Yes, right now it is HTTP because it's local, but we can absolutely create an SSL termination, no problem. Yeah, we have ingress protect. We could add all of that.
And from what I understand from the cowbells, I mean, the cowbells is actually a sort of a PC that's bolted onto the Rajant and just interfaces onto the network side. And you run containers on these CPUs that's on there. Why do we need to sort of do it on a cowbell? I mean, if you have that container for blast blocker as a OS, can you not run this on a server dedicated to this from our perspective?
Absolutely. I think that's a great question. I had an extra slide just for a question like that. Generally, there's a lot of value add for using cowbell versus a computer that you can buy off the shelf or a server that you could buy off the shelf. There are layers of, you can think of this as we have created enough utility within the cowbell software platform that we've basically taken about 2 to 3 years worth of engineering effort to simplify a lot of the things that an IT person would need to do, a DevOps person would need to be available, the machine learning engineer and data engineers to simplify a lot of the things that typically are done in an IoT ecosystem. So we have simplified integration with different sensors using a managed application that we have created called the Sensor Adapter Service. It reduces the integration time with additional sensors from several weeks to maybe even a day, depending on how good how easy it is, how difficult the SDK is for the sensor. We've created several utilities around video management and data pipelines that have been automated for consumption across other applications deployed within the cowbell. So we have standardized the data APIs. We have created ways to automate the pipelines for data storage and visualization into dashboards. We have created infrastructure for and distributed infrastructure, not just a single node infrastructure. We can create a cluster of nodes and provide the failure tolerance that you would need in an edge system like this. That's a fast deployable edge system like this. And we've also added orchestration and service discovery. These devices find themselves. We've basically automated a lot of the IT requirements that IT folks would need to come and set up your servers. We expect that if you have to deploy a system like the cowbell, you would just turn it on and applications come up, and really no management is required other than to see red, green, blue for the health, monitoring the health of your operations. And we've added things like, yeah, sorry.
But this is all contained into a container onto the cowbell's platform.
Yeah, I was about to touch that. So it's not, so cowbell can also orchestrate applications that are non-containerized. And cowbell is also independent, agnostic of the hardware and the operating system of your system. So you can run Windows applications, containerized applications, non-containerized applications, computers that are Linux-based, computers that are Mac OS based. Really, the cowbell software platform is agnostic to the the hardware that you put it on. But we have found a niche in integrating the networking component within Rajant's networking components into our platform, and certified some of the integration. And it's a tighter integration than somebody. Let me just put it this way. I think that it's a larger discussion about discussing the benefits of the cowbell, but if our objective, at least at this point, is that the value that we are generating by providing this software platform, the cowbell software platform, is so high that even if you were to give away the hardware for free, you would still not. If the competitors were to give away the hardware for free, it would still not be enough to. So that's kind of the objective for us. We've taken out the manual effort and the subject matter effort, expertise that is needed to operate a system on the fly. And it's also a mobile node, so you can put these things on trucks, you can put these things on light poles, you can put these things on in fixed infrastructure or mobile infrastructure. So our objective was slightly different when we created this.
I understand that perspective. So yeah, but from a perspective is, if you want to wanted to push this onto a existing VM or anything and have it as a container, it could be possible, but you've made it rather for all the other reasons you've provided as a platform for now.
Absolutely, and if you're interested in the Blast Blocker application, all applications we have developed and infrastructure that we have developed is cloud native. They are agnostic to the cloud. There is no dependency on any outside third-party software. So we can deploy containers on your. We can in fact deploy the software platform on your edge hardware. Of course it will take some certification, but yeah.
Yeah.
We have another question from Xander. Do you want to ask your question? I think you might be on mute. We can't hear him, so I'll read his question. He says, can you confirm whether Blast Blocker can integrate with a digital blasting tool to actively prevent a blasting command if a GPS-equipped device is detected within the blast zone?
I don't know enough to answer that question, so I probably need more information.
I would say at this point, we have not attempted to do any direct integration with digital blasting tools. If anybody would like to recommend their favorite digital blasting tool, we would be happy to do some research and look into how feasible that might be. Are there any additional questions from any of our Blast Supervisor customers that might be on the webinar before we do the live demo?
Todd, I still have some questions left, if it's okay.
Okay.
Okay, so the second portion to my question was from looking at this. I mean, you'll have to equip your people with the QStat. Again, the QStat is a wearable device. The antenna on that system is quite small. I mean, we all know that these devices don't have an extensive range. Now, imagine the size of the blasting in the pit areas where you've got agent-to-agent communication, that should be fine. But there might be areas where the QStat will not have reach onto the distance. I mean, I'm not too sure, but I expect this to be probably in the 80-meter range to agent node that you have to be in for the QStat to work.
So
Yeah,
let me
go ahead.
let me address that. So we have multiple tracking applications. We have a application called S-Track for tracking all the equipment and all the people in your mine. The Blast Blocker application is specifically who we're trying to track is specifically those individuals who are acting in the role of Blast Blocker for a blast operation. One of the responsibilities of a blast blocker is to make a visual inspection of their portion of the blast zone and then to block the access road. So blast blocker itself is not necessarily trying to track every employee in the mine. And the presumption is that the operator or blast blocker who's operating a machine or a light truck would be within a couple 100 feet of that machine or truck during the course of their blast blocker activities.
Yeah. From our perspective, we remove typically all the trailers and the Wi-Fi agent nodes out of the blasting zone because, I mean, you'll typically in our environments, the pits are quite deep. You have to have coverage down in the pit area where they do the blasting. And when we do the blasting, we take out the trailers, we take out most of the equipment there. So you will not sort of see if a blast person is still in that radius because of the distance. So that sort of creates a challenge in terms of that portion, because typically you'll remove some of your APs in that area.
So if I may address that in a slightly different train of thought, I mean, one of those things that our applications can also interface with other types of trackers and communication modalities. So one of the things is, I'm not sure if this is too relevant, but we've actually integrated LoRa-based asset tags, asset trackers as well. The issue with LoRa is that they don't have, depending on how many pings you have, they per second or per hour that you have, the battery life is pretty. It takes a lot of power to operate a LoRa-based device, but they provide the range that you might need. And with the same platform, we can integrate LoRa-based tags as well. And if a blasting operation is a few hours long or maybe even several hours long, I think a LoRa tag would, as long as you can keep them charged up before an event, that might work. All you need is at the edge of the blast zone have a LoRa gateway connected to the cowbell, and we have applications that we're developing that we can host a network server, LoRa network server on the cowbell itself, and pull data from these LoRa-based trackers with the same application. Really, no change. Yeah,
So
that's another option.
one other thing to keep in mind, we do understand that it is common practice prior to a blast to remove any solar trailers from the blast area and the safety zone around the blast area. The primary method for keeping your blast blockers safe is still going to be the two-way radio and the blast supervisor polling each of the blast blockers to say, did you inspect your area and was your area clear and have you moved back? The primary purpose of the blast blocker is to verify that they are back outside of the range of the safety zone, which the presumption is you would have network coverage around the perimeter of the safety zone, because that's the same distance you would have pulled your solar trailers back to, and you likely would have had other solar trailers providing coverage. As far as the Wi-Fi connection goes, one of the reasons we're recommending every light truck or machine being used for blast blocking has a breadcrumb with a GPS is it's the truck or machine that the blast blocker is in that's acting as the network infrastructure to transport that Wi-Fi connection. So the Wi-Fi connection in most cases is going to be 2 meters or less between the Q-stat and the machine or light truck breadcrumb. Only in worst case scenario, if the operator gets out of their machine or light truck, would they have a greater distance than that? And it's unlikely they're going to be more than a couple 100 feet from their machine or light truck during the blast blocker operation. Again, if you're looking for universal coverage for all your people in the mine and all the mine assets, we would not be recommending the blast blocker application. We would be recommending our S-Track, which is more of a universal tracking application and gives you a variety of methods for tracking with or without Wi-Fi infrastructure.
And that's a good point, Todd. I want to add one more thing, and we do actually consider assets that are offline that haven't reported in the last 15 seconds as offline, and offline assets are considered unsafe. So if they haven't actually reported in, they were supposed to be outside the blast zone and they haven't reported in, we would still consider them unsafe by default. And as soon as they come out of the safety blast zone, I'm sure that they would be within range of one of these access points, and automatically when they start sending their location in, that will be counted as they're online, and then you look at their distances, and then you make a safety assessment.
We've got 7 minutes left in our time. I think we need to move on to the demonstration, Muthu.
Sure, yeah.
And
Let me
if we don't get to your question, please send us an email. We would like your questions and your responses and suggestions.
All right, cool. So I'm just gonna kind of walk through some of these pages that we've built. This is the assets being people, equipment, haul trucks. You can see different kinds of assets. We've provisioned a few here, and one of these things is a haul truck. That's essentially a breadcrumb with a GPS. You can see details of information coming from that haul truck. This shows where the truck, I mean, it's been sitting outside my office, so that's why there's not a lot going on. But we could also see how many Q-stats are connected to it, what time. This is aggregated information, so you can see last 6 hours, and this is essentially data coming from our databases. We also can see live data coming from them. This is live, coming real time, and whenever there's another ping, so you could see data change, and there's some positional information and also some other operational information about the temperature, inside temperatures, and other things like that. So this is one type of asset we support. The other one is people Q-stats. I'm wearing 6323, so let me see where that is. So that's this guy. Let me go in here. This shows health vitals. I can see live data as well. Right now, I'm because I'm moving and my hands are shaking. My quality of my SpO2 is low, so we track that. It shows the battery percentage, heart rate values, temperature, and so on. And you can see that the peripheral is in session, meaning data is being archived. I currently don't have a GPS lock, so it's showing somewhere in the middle of the ocean on the right-hand side. And this device would now be considered offline. And so I can stop live. This shows historical information. At some point, I did have GPS connectivity, and I was able to go close to the windows. And that's why you see that information over there. So going back, this shows the dashboard. So we've created a project for a blast blocker session, and this shows the safety zone and the hazard zone. So let me do an example. So clear. This is a simple interface. You could before I clear that, let me kind of show you what you're seeing here. So there's equipment, people grayed out, show that they haven't reported in. But this one, Paul has a GPS lock, and it was seen 20 seconds ago. And as soon as they there's no regions, so now there is no safety statistics. So once I create the region, you will see it create the safety zone around it, and then it shows there are no safe assets. And as soon as these equipment enter the blast zone, which it did just now, you could see that there was an alarm that was generated, and you can see these alarms also in the alerts page down here. You can create different kinds of views. I want to see critical alerts, especially when you have vital alerts or proximity when you enter a blast zone. Those are the types of alerts you can see. Or you could do nice things like, I'm interested in a type of alert. So you could see these are low battery alerts. This one shows heart rate is low over a period of time. And activity, somebody's not moving for a long period of time. So they say this is a man down event. We could do nice things like that based on the vital information as well. So another thing I wanted to show you was, so let's say this was the download feature. So you could actually download one of these files, GeoJSON, as GeoJSON files. And if I were to clear this, and I can import it from that location, and it's as simple as that, importation. That's it. It's and of course I did talk about a lot of the different roles. So I can actually go into another role if you want.
We've got 1 minute, Muthu.
So maybe I'll just stop here then.
I would like to answer Rain's last question. He was asking if the QStat
Okay.
is a Wi-Fi client device. It is
Yes,
a
it is.
Wi-Fi client device. It's theoretically possible to use other devices to track people. One of the great advantages of using the QStat is because it has a heart rate monitor, you know that somebody hasn't taken the device off. We do understand that some people may elect or not want to be tracked, but we're trying to track people not to babysit them, but to ensure they're not in a hazardous zone. And by having a tracking device with a heart rate monitor, we can ensure that it notifies us if it's removed from the person's wrist.
Actually, Todd, to add to that, there's it's much more than just a heart rate monitor that provides our that metric of skin compliance, wearing compliance. We have sophisticated algorithms that we have built that not only determine that you're wearing the device, it's in proximity to a thing, but also ensures that it's a person that's wearing it. So typically, if you look at all of these Apple Watches and other things, you put them on a table, it still gives you a heart rate. And we've got sophisticated algorithms that we've created from the raw information that we can collect out of the QStat that enables this feature. And we use this for other things like drug studies and opioid addiction and other things like that, which is why compliance is a big deal for those applications, and which is why we built those applications.
Well, thank you everyone for joining. Again, if you have other questions you think of, or other ideas or suggestions that you'd like us to consider, we would love your input. You can email your Rajant sales rep, and they can pass on the information. And we're looking forward to bringing this application out in the near future. Thanks for joining.